Hello, everyone. My name is Malcolm, and I'll be presenting research that's comes from my master's thesis that was under the supervision of Dr. Mazdak Nik-Bakht and Dr. Amin Hammad. The health span of construction workers is reduced because of the nature of their work. As just one example, in 2019, 46% of US construction workers reported having musculoskeletal disorders, or MSDs. And this trend of lower back injuries or shoulder injuries and other MSDs is seen in other countries and for other construction trades. Occupational exoskeletons, or OEs, are an emerging class of ergonomic tools that are designed to target these areas of the body to prevent injury. Recent research that just came out of Polytechnique Montreal looked at over 2,000 MSD cases over a 3.5-year study period in a construction context, and found that the data they collected suggested that OEs, or occupational exoskeletons, had the potential to have prevented 50% of the injuries that they observed. So how do we develop an effective OE for the construction industry? Well, we can look at a framework from Van der Beek et al. That investigates this question for ergonomic interventions in general. And it starts by looking at injury statistics, looking at risk factors, and the mechanisms that link these two together, all to inform the development of an intervention, its evaluation, iterating the design when it's not yet effective, implementing an effective intervention, and hopefully seeing a reduction in injury rates in a population of workers. Other research has also looked specifically at roadmaps to guide future research towards large-scale OE adoption. And here's just a example framework that's kind of representative of many frameworks from Crea et al. That recommends or explains that we need efficacy or laboratory studies to inform effectiveness or field studies, and that these forms of research can lead to a holistic body of scientific knowledge that we need to support large-scale OE adoption. So after reviewing these similar frameworks and roadmaps, two main themes really stood out. And the first is the importance of surveying industry stakeholders, and the second is the importance of standardizing efficacy evaluation. So industry stakeholders, that just means workers, health professionals, standards development organizations, including ASTM Committee F48 on exoskeletons and exosuits, as well as trade school instructors and students. And standardizing efficacy evaluation is important because efficacy really means ensuring that the OEs we're developing are safe and that we can compare different designs under the same controlled conditions. While standardization is important because this can lead to benchmarking data. But specifically for the construction industry, there's two additional aspects that are really important that need to be added to this list for efficacy evaluation. And that is that these tests are trade specific and that they're realistic. And I'll explain why in the next slide. So this framework and this roadmap that we just looked at, although they're applicable to the construction industry, they're not sufficient for guiding future research on construction OEs. And that's because compared to manufacturing or the logistics industries, where exoskeleton research is more mature, the construction industry faces some exceptional challenges when it comes to designing and evaluating OEs. This is due to the intensity and the variability of the tasks and environments within each construction trade and between trades. And so if we're gonna have a framework and a roadmap to inform future research, they need to address these challenges with specific mechanisms. So here is our framework that we're proposing and to guide OE adoption in the construction industry. And at a high level, it involves looking at injury statistics, designing an exoskeleton, evaluating it, and implementing an exoskeleton that is effective at reducing injuries and implementing it at a large scale. The design phase mimics what we saw in Van der Beek et al.'s framework earlier, but this next part is a novel component, and it's a decision. Does the exoskeleton meet a set of minimum design requirements for the specific construction trade that we're looking at? If it does, or first of all, if it doesn't, we should iterate the design. If it does, then we can move on to a short-term evaluation, which we hope will provide sufficient evidence of the exoskeleton's efficacy. If it does, we can in turn move on to a longer-term evaluation, which we hope will provide sufficient evidence of the exoskeleton truly reducing injury rates in a large population of a large sample of workers. And if this is found to be true, then we can move on to large-scale adoption. And these three decision points should be informed by stakeholders, specifically a trade-specific industry stakeholder survey. So there are two novel aspects to this framework. And the first is what we just went over, these three decision points. But the second novel aspect is within the short-term evaluation phase. And this is a set of general and trade-specific, realistic, and standard efficacy tests. And that's a lot of descriptors at once, so I apologize, but I'll give a more concrete example in the next slide. But all this to say that these novel aspects of the framework, highlighted in blue, are there to overcome the design and evaluation challenges inherent to the construction industry, which is, to say it again, the intensity and variability of construction tasks and environments. Along with the framework, we're also proposing a roadmap for future research. And this roadmap the goals of this roadmap can be visualized as a set of trade-specific surveys and as a set of standard tests. We could talk more about this after the presentation, but for now, I'll just highlight that we've started on the standard testing front. And right now we're collaborating with ASTM Committee F48 on exoskeletons and exosuits to propose a standard test for rebar workers. And here's the research that is supporting this, kind of behind this standard test. And this was a collaboration that we did with the Steel Trades Training Center here in Montreal, and also with the exoskeleton producer, BioLift Technologies. As a continuation of this research, we conducted a pilot field study. This took place over 3 days and with only 3 participants. And it involved constructing a concrete slab with 3 experienced construction workers wearing the BioLift exoskeleton. So this is a small sample size and a short duration, study duration. But the goal of this test was really just to investigate the realism of the standard test in the previous slide and compare, and also to see in which ways we can measure an OE's effects in the field. So we measured objective and subjective data in the pilot field study. And these data, although they weren't statistically significant, they allowed us to see ways in which the framework and the research that would come out of the framework we're proposing would have helped us make better decisions for the test. So I'll just name 2 challenges that we face and how the framework would have helped, but there's a lot more examples in our paper. As a first example, you can see in the image on the right, one participant commented that while he was kneeling to tie rebar, the exoskeleton was uncomfortable. And at first glance, this looks like a limitation of the exoskeleton itself. But as we learned in our previous research, tying rebar is a learned skill. And experience level really depends what posture you choose while you tie rebar. And so a set of minimum design requirements for exoskeletons for the rebar trade would have helped us decide whether this was a limitation of the exoskeleton itself or a limitation of our study conditions. As a second example, although we measured trunk flexion using inertial motion capture, in the end, this data wasn't usable, and this is because the research backing up the precision of non-optical methods of motion capture is not very mature, and so we couldn't conclude anything from the motion capture data. So again, if we had data on what would be important to measure to generate sufficient evidence of effectiveness in the field, this would have informed the choices we made when choosing what measures we wanted to bring into, to bring into this field study. So this framework for OE adoption and construction, here I just presented a couple examples and from one construction trade. But we believe if we move towards the roadmap goals, and if future research moves towards the goals, then it'll lead to increasingly beneficial research and standards. So trade workers are essential for our built environment, and they're essential to our society. If we can figure out what each trade needs from an OE, from an occupational exoskeleton, and how to measure that OE, then any advancements that we make in robotics can have direct benefits for these essential workers and for their well-being. Thank you very much, and I appreciate your time.